Hello, my name is Simon Monk, and I'm going to be giving you a quick sort of whirlwind tour of programming the BeagleBone Black using BoneScript. My job is writing books about open source hardware technology, so I have books about the BeagleBone, Raspberry Pi, the Arduino, and also some general electronic texts as well. So the BeagleBone Black, I'm sure you've seen there's a lot of interest in it in the BeagleBone Black this year. This little board, I think they're about $45, something like that. Looks superficially a little bit like an Arduino board or a Raspberry Pi board, and in fact it's got things in common with both of them. It's a single board Linux computer. It's got at the moment, the versions that are out there already, which are revision 1 and revision 2, use a distribution of Linux called Armstrong. The newest distribution, the newest revision, revision C, which is just starting to ship, uses Debian Linux rather than Armstrong. These devices can either boot directly from a memory chip, a flash memory chip on the actual board, or you can plug an SD card, micro SD card into the end here, and then you can have it either transfer the contents of that micro SD onto the main flash on the board and it kind of flash the entire board to a new distribution, or you can have it run directly off the micro SD card. You get a choice in that respect. So if you look at some of the features of the BeagleBone Black, you'll see that we've got one thing that makes it different from other single board computers is that we've got lots of GPIO connections. So you can attach electronic hardware to the BeagleBone Black using these two big connectors here, two double rows of sockets that you can plug electronics into. Some of the other things to point out on the board are an Ethernet jack so that you can plug it into your network. At the opposite end we have a USB host socket, so you can plug keyboard and mice into there. So you might want to attach a USB hub and then connect up all your USB devices, or you might want to plug a Wi-Fi adapter in so that you can actually take the whole board mobile and have it connected to your network in a mobile manner, which is of course a good way if you were using this as, say, the controller for a robot, and then you could send commands. It could be a web server and you could send commands to it. It has a micro HDMI output, so for that you would need to connect up a little adapter, and then you'd be able to plug it into your monitor or TV. So you really can set up an entire home Linux system using this little board. Okay, when it comes to programming the BeagleBone Black, the sort of interest that I have in this is for programming it to control electronics in the same sort of way as you would an Arduino. And for that, the choices really are that you can use Python, which is a very common programming language. Lots of kids are learning to use Python at school. You can also program it in C, and you can program it in BoneScript. And BoneScript is kind of as much as anything, is the standard language for programming the BeagleBone Black. If you go to the beagleboard.org website, once you've bought your new board and you've plugged it in, you'll find instructions there that lead you through using BoneScript to program the BeagleBone Black. So this talk is going to be about using BoneScript. So what is BoneScript? Well, to answer that question, we really need to know a little bit more about how all the software is stacked up on this device. So we have JavaScript, which is originally a browser language, and it's often used in websites so that you can do things like, you could have countdown timers that are implemented that run actually on a browser. Okay. However, JavaScript is not really is not originally designed for running on a server, and when you're running JavaScript off the browser, in other words on a server or some other kind of machine like a BeagleBone, then you use a variation of JavaScript called node.js to give it its proper name. So BoneScript, the actual language we're really going to talk about, is a library for controlling the hardware, the library for turning these input-output pins on and off, saying whether they should be inputs or outputs, reading analog values from them, all those sorts of things. It's a library for doing that in JavaScript on Node.js. And the way that you connect to a BeagleBone Black when you want to program it is that you actually, the BeagleBone Black, when you turn it on, as soon as you plug it into USB, that will power it up, and it will also start it running as a little web server. And not just a little web server that serves a bit of content about the BeagleBone Black, but also a web server that hosts a web-based integrated development environment, which is called Cloud9. And this Cloud9 IDE allows you to write programs actually on the BeagleBone Black and then store them on the BeagleBone Black's file system, all through a web interface. So your way of communicating with the BeagleBone Black is to use a browser on your laptop, for example. So let's just, I'm going to start a little demo up just to demonstrate that. So I'll come out of the presentation, and if we go over to a browser, we can see here that this browser, if you can just about read the URL bar at the top, it says 192.168.7.2 and then colon 3000 because it's running on port 3000. And this web address here is actually it's using the USB connection as a sort of pseudo network connection to the BeagleBone Black. So you don't even have to plug your BeagleBone Black into your home hub or into your local network. You can actually connect to it as a network device through the USB connection that's also powering it. So this web page here is actually showing a page from the integrated development environment that's being served up by the BeagleBone Black. So on the left-hand side of the screen we have a sort of our project explorer where you can see all the different files that are available, and you can see I've organized a folder here called Bay Area Maker Faire 2014, and then here I've got the programs that I'm going to run in this demonstration. So one of these is already loaded up here, and it's actually called Blink built-in. So the BeagleBone Black has a number of built-in LEDs actually on the board, and you can control them programmatically as well as being able to control all the GPIO pins on these connectors. So let's just run this program, and to run it I'm just going to click on the run button here, but if I could just ask the control desk, could you switch over to show the desktop please? Could you switch? Thank you. Okay, so you can probably see we've got the BeagleBoard here, and the area to look at is just over here by the side of the Ethernet connector, and I'll run the program. And can you see the LED blinking on there? Okay, good. It's not that exciting, is it? It's more exciting when you attach some extra hardware to it. So let's just go and see how that code worked to get it to do that. So if we could switch back to the computer, please. And I'll go back to the presentation. Okay, slideshow, play from current slide. So here's the code that does that makes the LEDs blink. And if you've done any JavaScript, then you'll follow this fairly easily. If you haven't done JavaScript, then it'll probably all look a bit mysterious and a bit unusual, particularly if you're sort of used to an Arduino background, which does things in rather a different way. So if we start at the top of the code, we see we've got this var b equals require BoneScript. This is how you import a library into JavaScript. And then on the next line, we've got a variable called LED, and we've assigned that the string user3, USR3. So that refers to this LED on here that's blinking. You have 4 LEDs, USR0 to USR3, that you can control there. So if we wanted to turn one of the I/O pins on here on and off instead, and I'll show you that in a minute, then we would just use a different value in there instead of the LED. On the next line, we are specifying that we want that LED pin to be an output. So we do that by, we've got this handle B, this variable B, which is the BoneScript library. So we're basically saying, telling the BoneScript library, make the pin mode of the LED be an output. We then have a variable here that we use to keep track of whether the LED is on or off. And then we have a function here that toggles the LED. So what that does is it takes the state variable, and if it's initially 1, it turns it to be 0. If it's 0, it turns it to be 1. So it inverts the value of this variable. And then finally, inside this function, we have B, so BoneScript, digital write the LED to whatever the value is of state. So either 1, turn the LED on, 0, turn the LED off. So we've put all of this in a function, but what we now need to be able to do is to be able to run that function every half a second to make the LED toggle between being on and off every half second. And we do that with a JavaScript thing called an interval timer. So we do set interval, then we specify the function that we want to run, which is called toggle LED, and then we specify the period in milliseconds that it should be run. So this will run toggle LED every half second, blinking the LED on or off. Okay, so that was the built-in LED, not terribly exciting. If we wanted to connect an external LED, then we could do it like this. We've just got here a bit of breadboard. We've got a ground connection, that's the blue wire coming from one of the connectors on the BeagleBone Black. And then we've got an LED in series with a current limiting resistor connected by this orange lead to one of the GPIO pins of the BeagleBone Black. So I'm not going to show you that today, but I'm going to show you something a little bit more exciting, which is we don't have to just control an LED. In a way, an LED is not that exciting a thing to control. A big old-fashioned light bulb of the sort that you'd get in the tail light of your car is a bit more interesting, but it takes too much current to be able to directly drive. Well, it takes a lot too much current to be able to directly drive a bulb like this from one of the connectors on the BeagleBone. So we use a transistor, which is this thing here, to actually amplify the current and allow it to switch the bulb on or off using an external power supply. So we're going to use this little battery pack to control the LEDs. So you can see on the diagram there how this is wired up. There's a transistor, there's a little resistor that limits the current going into the transistor, and then the transistor is basically switching the current to the bulb that is supplied through this battery connector here. This is all built on one of these Adafruit boards that you can buy as a kit, and they're intended for prototyping. So they just have, you just solder the connection pins and then it will plug on top of the BeagleBone Black like that, and then you solder your own components in this middle area here. So if you want to build a simple prototype to do something like this, then this is a great way of doing that. These shields are very inexpensive to buy. So let's connect that up and do a little demonstration. So I'll switch back to the development environment, which is of course on our browser, and I'll close that program, and I'm going to fetch up another program called Blink Light Bulb. So you can see the program is almost identical. The only thing that's really changed is the pin that we're using for the LED. So we've changed that to be P9_14. So the Beagle board has two rows of connectors, one called P9 and one called P8, and then the individual connections on each of them is the bit after the underscore. So we're using P9 underscore 14, which is one of the ones round about here, to actually control the transistor that's going to control the light bulb and turn it on and off. So we'll just wire this up now. So I'll pop this on here, like that. Plug in the power supply. Okay, so now when we run the program, stop the old program running, run the new program. Okay, so a bit more exciting. Could we just switch to the thing for a moment? So there we go, a light bulb. Although this is using a light bulb, there is no reason why you couldn't use something more sophisticated. So you could use a relay, say, that controlled a big motor or anything, or a mechanical door lock or something like that. So the basic principle is you can use a transistor, control quite high current from one of these little GPIO pins. Okay, if we could switch back to the presentation, please. Back to the... Thanks. So let's continue with that. So what we've been doing so far is digital outputs. We're changing a pin on the connector here to be from being on to being off. They're digital outputs. The pins on the BeagleBone Black are capable of a lot more than that. You can use them as digital outputs, but you can also use them as digital inputs, so you can connect switches to the BeagleBone Black and detect whether the switch has been pressed or not in your programs. You can use analog inputs, so you can measure voltages and then do something with those voltages and display them, for example. So this is a pinout. It's probably too small to see properly on the screen, but you'll get an idea that there are lots of pins available to you. Most of them can be used as digital inputs and outputs. Some of them can be used as analog outputs, and some of them can be used as analog inputs. So a real mixture there. As an example, if we were going to use digital inputs, then we might want to, say, wire up a couple of switches and an LED like this. So you can see that if you follow the blue wire first, you'll see there's a blue wire that comes out of the Beagle board, and this is the ground wire. It's the sort of common reference 0 voltage, the ground wire, and it's connected via this bus wire down the side of the breadboard to the bottom side of one switch and the bottom side of the other switch. Okay, so each of the switches at the top end of the switch then is connected to one of the GPIO pins. You'll notice that there's also a little resistor here, this for each of the switches, that actually connects that same top end of the switch that's connected to the GPIO pin. The resistor bridges that up to the positive supply voltage, the 3.3 volt supply on the Beagle board. And this is called a pull-up resistor. And the idea is that when the switch isn't pressed, the input is all permanently being pulled up to 3 volts. And then when you do press the switch, it effectively shorts that input down to ground, and the input value is then at 0 volts. Okay, so you have to use this kind of approach with a pull-up resistor. Otherwise, the input could float, and it could sit at some indeterminate state, and you don't know whether it's a 1 or a 0, and if it picks up electrical noise, it could switch between the two and be very confusing. The code for doing digital inputs is very similar to the code we saw before for doing a digital output. You first of all have to import the BoneScript library, so we do the B equals require, and then we've got this variable B that's a reference to the library. So every time we want to do something with the library, we have to say B dot and then the command to do something with it. We've got a pin variable that we're going to use for the switch pin that we said is going to be P912, and this time we do B.pin mode pin B.input. So we're specifying that pin is an input. We've then got another function here called read input, and then what we have here is that it uses another variable that reads a value from the digital input from the pin specified in our variable up here. And that reading will either be 1 or 0. It will be on or off, true or false. And then finally, to repeatedly read the input, then we're using an interval timer, so it sets interval, so once a second it's going to read the input and check it. That's not completely satisfactory, because what happens if you're using a button and you quickly press it and it's gone down and back up again before it's had time to register it? So there are more advanced features that are something called interrupts that essentially mean that the function will only actually get run when the button is pressed. But it does rather depend what type of input you're using, whether you want to have it trigger an interrupt, or whether you just want to keep what's called polling and checking the value of the digital input. Okay, so that's enough about digital inputs at this kind of introductory stage. Analog inputs. One of the big differences between the BeagleBone and the Raspberry Pi is that the Raspberry Pi doesn't have any analog inputs. If you want to connect analog devices to it, you have to you do some special tricks. It can't directly measure voltages. You can tell you whether a voltage is above or below a threshold, so it can just say, is it a 1 or is it a 0? Is it above 1.6 volts or below 1.6 volts? But it can't measure the voltage and say, yep, that's 0.8 of a volt, or that's 1.2 volts, or whatever. But the BeagleBone Black does have these analog inputs. So you might want to connect up a light sensor. So what we've got here is we've got a photoresistor, that's what this thing is here, and we've got a fixed value resistor here. And these are arranged in what's called a potential divider. So we've got the top end of the photoresistor is connected to a positive supply. Where the photoresistor and the fixed value resistor meet is connected to one of the analog inputs of the BeagleBone, and the bottom of the resistor, this blue wire here, is connected to a ground connection of the BeagleBone Black. So if you're used to Arduino, then be a little bit careful when you come to use the BeagleBone Black, because the Arduino has analog inputs that are 5 volts. You can put any voltage in up to 5 volts. The BeagleBone Black, the maximum voltage that it will read is 1.8 volts. So you have to be careful not to exceed that. As well as providing, I think, 6 analog inputs that will measure a voltage between 0 and 1.8 volts, it also provides high quality ground and 1.8 volt references. So that if you're doing an arrangement like this where you're using some kind of potential divider, you know that you're getting an accurate supply for the top end of what you're measuring, by using these special analog reference pins that are available on the GPIO connector. The code for reading analog inputs is a little bit different from what we've been looked at so far. So again, we require the BoneScript library, and then here we've got a function called readLight, and we're just going to call readLight on this interval timer down here, so that every half a second it's going to call this function. But there's something interesting going on here, because if you look inside this function, all it does is do b.analogRead, and it specifies a pin to use, so P939, which is one of the analog input pins. And then this thing here is the name of a function. Because the analog read could potentially take a little bit of time, the JavaScript way of doing things is that you use callbacks. So what we're basically saying to the BeagleBone here is, go ahead and take an analog reading, and when you finish taking that reading, call this function called displayLight. And the displayLight function is what's actually going to, oh, sorry about that, is what's actually going to print out a value for us for the light intensity. So when this callback happens and displayLight gets called, it gets passed a parameter, which is the reading. We do a bit of maths on that to turn that into a voltage, and then this line that says console.log will just write out the voltage on the command line for us so that we can see the reading. You might want to do other things like control the brightness of a light, or if the reading that you get is above a certain threshold, you might want to turn on a digital output. So let's say you had a temperature sensor, read the temperature. If it's above a certain amount, it might flip a relay that turns on the air conditioning, for example, to make yourself a simple thermostat. Okay, so that's analog inputs. As well as analog inputs, the BeagleBone Black can also do different types of pulsed outputs, which are rather equivalent to analog outputs. So you can do PWM, which stands for pulse width modulation, which is all about controlling power. So you send out little kicks of power that would then control the speed of a motor or the brightness of a light bulb, that kind of thing. The other kind of pulsed outputs that you can get from quite a big range of the pins on the BeagleBone Black is called pulse cone modulation, which is what you use for setting the position of a servo arm. So you can control a number of servo motors directly from a BeagleBone Black using a digital output. So just looking very quickly at the pulse width modulation side of things, controlling the power, it's very straightforward. Again, you have to include the BoneScript library, and then you just do b.analog write, and then you specify the pin that you want to write, and then this value here is between 0 and 1. So 0 means no power at all, and if it's 1, that means full power, so that the device will be receiving the whole of the duty cycle and be completely on. Okay, so to summarize, using this kind of using the BoneScript language is quite a different approach from Python or C that you'd use if you're using an Arduino. You use callbacks so that when something has happened, like an analog reading has been completed, it takes some further action. It calls another function in code. And you also use timers, so you use these event timers. So whereas in an Arduino or in Python you might delay or sleep for half a second and then move on to the next line of code, in script and BoneScript you actually set a timer to say do something at this period. And we have this nice web-based integrated development environment that lets you actually program the BeagleBone Black using a web interface that's running on the BeagleBone itself, which is a very nice touch. Okay, if you want to see a more advanced session that looks at controlling the BeagleBone Black using a web interface, then I'm here again tomorrow. Please check the time, because I'm not absolutely sure that time is correct. I know there's been a few changes to the schedule, but I'll be here again there talking about that. Take a look at the official BeagleBoard site. There's loads of really good information on there. And of course I have to say my book, which is out now, Programming the BeagleBone Black by me, Simon Monk. All the code that I've been describing here is also available on my GitHub site. So if you go to GitHub and you look in Simon Monk, you'll find a number of BeagleBone Black related repositories there where you can pick out the code that I've been using today. Okay, that's it, I think. Do we have a few seconds for any questions or anything?